All right, welcome back. This is at THS Mr. Jones, and we're going to talk about chapter 4.6, which is the last section in chapter 4, and it talks about rational functions. Now, rational functions are any form of f of x equals n of x over d of x. So any fraction, okay? Now, here's the thing. These are both expressions with x in it, okay? And this bottom cannot be 0, but it also cannot be a constant. If it is a constant, then we just have a normal polynomial. Now, there are a couple very important things that we want to know about fractional exponents or rational functions. And number one is vertical asymptotes. Okay, and how do I find a vertical, or what is a vertical asymptote? Well, if we have a graph here, let's just start off with an asymptote. An asymptote is an imaginary line that your graph can approach. Okay, it normally doesn't cross it. There's one case where your graph does cross the asymptote, but your graph, it's an imaginary line that your graph gets closer and closer and closer to. So if we look at a vertical asymptote, maybe something like that, my graph could come like this, and it will get closer and closer and closer and closer and closer to that imaginary line there, almost like the underground dog fences that you don't see. Your dog doesn't cross it, but can get very, very close to it. Okay, and how do I find these vertical asymptotes? Well, if you have your function, let's say this is your rational function. Your vertical asymptote is where d of x equals 0. Okay, so you're going to basically find the zeros of your denominator. So let's say that we have x squared minus x minus 6 on the bottom. Okay, well, if I see where does that equal 0, we factor it. Factors of 6, that subtract a 1, that's 3 and 2. Signs are different, the bigger one's negative. So x equals 3 and minus 2. So at those 2 points, this would be 3, and this right here would be minus 2. I have vertical asymptotes at those 2 points. So your vertical asymptote is where your denominator equals 0. We also have horizontal asymptotes. So number 2. Horizontal asymptotes. Okay, now, like the vertical asymptote, it is an imaginary line that your graph will approach. Now, in these, sometimes your graph does cross. Okay, so I could have a graph that looks like this, and it approaches that line. We could come from the top this way, and it approaches that line. We could also do something like this, and it still will approach that line later on. So how do I find these horizontal asymptotes? Well, there's 3 cases. Number 1, if the degree of the numerator is less than the degree of the denominator. Okay, so we're going to use t is degree of numerator, and d is degree of denominator. So if the degree of the numerator is less than the degree of the denominator, then y equals 0 is your horizontal asymptote. So if you have a higher exponent in the bottom than you do in the top, y equals 0 is your horizontal asymptote. Number 2, if the degrees are the same, okay, then y equals your leading coefficients over each other. So leading over leading coefficient. Okay, so you'll take the leading coefficient of the top over the leading coefficient of the bottom, and that will be your horizontal asymptote. And the other case we have is if the degree of the top is bigger than the degree of the bottom. So if the degree of the numerator is greater than the degree of the denominator, then there is none. Okay, and in that case, we probably have some dividing to do. So we have a horizontal, we have a vertical, but then we also have what's called a slant asymptote. Now, a slant asymptote is a little bit strange, and we don't really graph a whole lot. And what it is it's just some imaginary line that is not horizontal or vertical, and my line will still approach it. Okay, so maybe my line comes up like this. Okay, later on we'll deal with 2 slant asymptotes. So maybe I have something like this here. So I've got that picture, but I also have this one over here. Okay, and they're just any non-vertical or horizontal asymptote is a slant asymptote. We do no more than just finding out what they are. So how do I find a slant asymptote? Okay, so if the top, so your top degree is one more than the bottom, then you're going to divide and your non-remainder solution is your asymptote. Okay, so for example, real quick, if I have 4x to the third plus x squared plus 3 over x squared minus x plus 1. Notice my degrees are different by 1. This one's bigger by 1 than this one. So we will do the long division. Okay, so 4x to the third plus x squared plus 0x plus 3 x squared minus x plus 1. And whatever I get, say I get, let's see, 4x plus 5, and then I may get a remainder of like x minus 2 over x squared minus x plus 1. Okay. Whatever your answer is that's not your remainder, we'll say y equals that part, and that is your slant asymptote. We can ignore this part over there. Okay. So that's how you find your slant asymptote. Okay. So when I go to graph these things, there are 6 steps to graphing. And when I grade your quizzes and your test questions, I'm going to look for these 6 things. So you may number them 1, 2, 3, 4, 5, 6. So number 1 is find domain. Okay, we've talked about finding the domain, what x can and cannot be. That's solely based on the denominator. Okay, remember, you cannot have 0 on the bottom. Step 2 are find your x-intercept, or your x and y intercepts. So find x and y intercepts. Okay, that is 0 comma y for your y-intercept and x comma 0 for your x-intercept. You got to find out where those are. Step 3 is find any holes. Okay. Now, a hole, we'll talk about it here in a second on how to find holes. Okay. So step 4 is to find any asymptotes. Which is what we just talked about. Seeing where the bottom equals 0, seeing the degree of the top and the bottom, and then dividing for the slant asymptote if needed. Step 5, make table. And find more points. And number 6 is to sketch graph. Okay. Now, finding a hole. Sometimes in situations with a fractional exponent or fractional equation here, you may be able to factor the top and the bottom out. Okay, so let me see if I can find something here. Okay, let's look at this. If I had this and I were to factor, let's put that there and we'll say this. Let's say with my original, I was able to do this and factor it out. Now you notice here that these x's and these x plus 2's can cancel out. Well, wherever I can cancel will create a hole in my graph. So we will have a hole at x equals 0 and -2. That's where we get the holes. So when we're talking about holes, we're talking about, well, what was able to cancel? And that will create just a jumping point. So my graph has to jump over that. So it approaches it and then makes a hole. All right, that's going to be all for 4.6. Okay, we've got some suggested problems here. Looks like starting on page 460. Numbers 5, 9, 11, 15, 21, 23, 27, 29, 31. Those are just matching some graphs up. 33, 41, 45, Oop, I forgot 43. 61. 65. And then let's check on the mistake problems. Catch the mistake problems, and let's do number 75. Okay. Your video questions are number 1. Question number 1 is, how do I find the vertical asymptotes? How do I find those vertical asymptotes? Number 2. Number 2 is, of the 6 steps, which one's going to be the hardest? Okay, so what step might be most difficult? Okay, which one might be most difficult for you? Okay, everybody's going to have a different answer. So what step in there is going to be most difficult? All right, and that is chapter 4.6. If you got any questions, please let me know. This is at THS Mr. Jones signing off.